Hey everyone, welcome to the Chapter 11 review. This is Nick Jacobs, your math instructor here at Yavapai College for intermediate algebra. I wanted to go through quite an extensive review of Chapter 11 as we kind of end what I will call the shortest, longest chapter. It's only 4 sections, but like you've noticed, the lectures have been a little bit longer. There's just so much information to cover. And maybe it's not as much information as it just takes a while to do some of the problems. But let's get started. And basically what I'm going to do is I'm going to overview each individual section, and then I'll do some example problems from the Chapter 11 practice exam for you guys to look at. And a lot of those will be very similar to the questions, again, that you'll see on your Chapter 11 test. So pay close attention to those. And let's get started here. So section 11.1, the quadratic function. Okay, so this is when we kind of introduced the quadratic function. By the way, quadratics are also known as parabolas, right? Because probably remember that. So they're also called parabolas. But the quadratic function really is equal to, so it's f of x equals, and this is the standard form, ax squared plus bx plus c. And basically, we know that it's quadratic, okay? So we can call it quadratic. So we know it's quadratic, or a parabola because of the x squared term, right? Because it has one term that has a x squared value in it. That's why we can call it a quadratic. Now, a couple of just quick notes on this function, right? A quadratic function is a U-shaped function, right? And either it is opening up or it opens down. Well, we know that it opens up, so it kind of looks like this. If a is equal, or sorry, if a is greater than 0. Right? So we know that it opens up if a is greater than 0 in our function equation. And we know here that it opens down like so if a is less than 0. Okay. And what we call the lowest point and the highest point is the vertex, right? We call this guy and this guy, those are the vertex or the vertices. Okay, I'll just kind of make a little bit of note there. And again, in this one, the vertex is going to be the minimum point of this quadratic. And then in the bottom one down here, the vertex is going to be the maximum point of the quadratic. And we'll cover an example here later of the minimum point. I also covered an example of the maximum point in section 11.1 as well. Now, some other things that we learned about quadratics. We learned the formula for the vertex, right? So the vertex formula kind of goes something like this. Well, the x coordinate of the vertex, is equal to negative b over 2a. So we take our function, f of x equals ax squared plus bx plus c, and we just identify what b and a are, and then substitute them into the formula. And then the y coordinate of the vertex, again, the vertex is going to be an xy point, right? So it'll be an ordered pair, right? The vertex is going to be some point x comma y. And we know that in the notes and things like that, they say that it's h comma k, but thinking x coordinate and y coordinate, with the x coordinate being h, the y coordinate being k, the y coordinate, we're just going to substitute whatever we get for the x coordinate back into the original function. So we're going to take f of negative b of 2a. So we just plug in what we get for x back into the function, and that gets us our y coordinate basically. Okay. And I'll demonstrate that here with some examples as well. So I thought maybe I would need another slide to do an overview, but I didn't. So let's move on. question 5. So this is the chapter 11 practice exam. I chose question 5 here to kind of give an example to start off with. So actually, you know what? I'm going to go back. I did want to do one more example. So if I have something, for example, like we're finding the vertex. Okay, so directions here will be to find the vertex. Okay, given, let's make up a function here. F of x equals, let's say something weird, -3/2 x squared minus 6x plus 1. Okay, so the first thing you do is you identify a and b. Sometimes I also identify c in there as well. And I just do that because later on when we're using the quadratic formula, we will have to identify it anyway. So that's kind of why I do that. But a is equal to -3/2. It's the coefficient in front of x squared. B is equal to -6, again, the coefficient in front of x. And then c, we don't need it for the vertex, but c is equal to 1. So then what we do again is we have our formula to find the x value, -b/2a, and we substitute in here. So b is equal to -6. So we have negative times a -6, be careful on that, all over 2 times a, so all over 2 times 3/2. And on the top here, we would have 6, right? Negative and a negative over, this would simplify to -3. So our x coordinate there is -2. And then again, what we would do here is we would take this and we would just plug in -2 for x in our original function to get the y value again, which is really f of -2 in this case. So we plug in -2 for x, and then that gives us our y value. It's really that easy. Okay, you just need to pretty much just be careful of your signs and things like that, and try not to make mistakes as you go along. But I will kind of simplify this down. Let's see, all this is going to end up giving us eventually, this part is going to give us a -6. So -6 plus 12 and 1 is 13. -6 plus 13 is 7, +7. So then our vertex here is going to be at -2, 7. Again, it's a coordinate point on your graph. Okay, and just a quick note here, note that y equals 7 is the maximum point, is the maximum, or we could say again, just our vertex, -2, 7 is the maximum point in this. And why is that? So why is this? Well, because, that's why, because why? A is less than 0. So we said on the last slide that if a is less than 0, our vertex is going to be a maximum. And that's exactly what it is here. A is -3/2, so it's a maximum. All right, now on to question 5 on the practice exam. So do the following for the given f of x, so the given quadratic function. Identify the vertex and the axis of symmetry on the graph. Graph y equals f of x. Evaluate f of -1 and f of -2. So let's go ahead here and let's identify the vertex. So we need to find the vertex first. So we need to find, oops, I keep writing that. We need to find a, which is 1 here. By the way, a is 1. This is going to be opening up, right? Because we have a positive a value. B is equal to 1 and C is equal to -3. Again, we don't need C for the vertex, but sometimes I just do it anyway, just because. So let's use our formula to find the x coordinate of the vertex, -b/2a. So I'd have -1 over 2 times 1, which is -1/2. And then the y coordinate there, I'm just going to substitute -1/2 back into my equation, my original equation of the function. And that is all going to simplify down to, let's see, that's 1/4 plus -1/2 minus 3, which is -3¼ or -3.25. And oh, by the way, this is also -0.5. And actually, when you are answering your question here, you do want to put it in decimal form. Otherwise, it won't mark it correct for some reason. So write your vertex in decimal form. I think the instructions say to write it as an integer or a fraction. So you also could write it maybe as a mixed fraction. Or no, I think it says integer or decimal. So an integer is a whole number, kind of, including negatives. So obviously these are not whole numbers; those are rational numbers. So we don't want to mix that up. But anyway, the axis of symmetry, if you guys remember that, is x equals whatever. And it actually is this negative b over 2a. So it's actually x equals negative b over, negative b over 2a, just written in equation form. So the axis of symmetry, I'll just call it axis of sim, is equal to x equals negative 0.5 or negative 1/2. Okay, so we have our vertex here, and then this is our axis of symmetry here. And now for part B, they want us to graph it. So we have to plot our vertex, and your graphs are pretty nice. They kind of, they tell you what points you're graphing. So negative 0.5, negative 3.25 is about right here. And then something that we could do to graph it, I'll just call this part B, this was part A. Something we could do to graph it is to make our XY table. I can just pick some values for X. So maybe, like 0 would be a good value to plug into this function. And that's because if I have 0 squared, that's 0. Plus 0 minus 3, that's just going to be minus 3. So another point here would be at 0, negative 3. Again, I just plugged in 0 into our original function. And then I could also maybe plug in negative 1. So go ahead and plug negative 1 into the original function. And that's going to give us 1 minus 4, basically. So that's going to give us negative 3 as well. So I'd have a point here at negative 1, 3. And if you wanted to, you could find the x-intercepts, which actually will be the solution to this equation, but we haven't done that yet. So all we're doing is graphing this. We'll do that later on in this lecture. Okay, so you have done it, just we haven't learned it yet in section 11.1. But then the last two things are evaluate f of negative 1 and f of negative 2. So f of negative 1 just means when x is 1, what is y? So all we do is plug in, sorry, I said probably 1. When x is negative 1, what is y? And we just did that right here. Okay, we got negative 3. And then they also wanted f of 2. And so if we plug 2 into the original equation, so 2 squared plus 2 minus 3, so 4 plus 2 is 6, 6 minus 3 is 3. So we have when f is negative 1, it's negative 3. When when x is 2, y is 3. So those are your answers. And again, this graph isn't 100% accurate. I just needed to sketch it here. When you graph it and you graph your 3 points there, it will be 100% accurate. You'll just need to graph the vertex and then whatever 2 other points that you choose. All right, and then number 6, they wanted us to calculate the minimum value on the graph, okay? And again, I had an example of the maximum value. Why is this a minimum value? Okay, why is this a minimum value? And it's because the a value is greater than 0. Remember, our function here for just any quadratic, just our general standard form, is ax squared plus bx plus c. And again, in this case, a is equal to 1, b is equal to 10, and c is equal to negative 5. Well, because a is equal to 1, a is greater than 0, which means it is a minimum, right? It means our function is going to be shaped like this. It's going to be U-shaped, not an upside down U. So let's go ahead and find what the minimum y value is. Well, the minimum y value is just the y value of the vertex. So if the vertex is x comma y, then we need to find x first and then find our y value. So let's go ahead and do that. So we know how to find our x value. That's negative b over 2a. So we have negative 10 over 2 times 1, which is just negative 5. And then to find the y coordinate, again, I just substitute the negative 5 in wherever I see an x in my original function, and then simplify from there. So I have 25 minus 50 minus 5, which is negative 30. So the minimum y value is negative 30. And again, the vertex on this one is actually, the vertex is actually going to be at negative 5 comma negative 30. But again, when they want the y value or the minimum value, they just want the y. All right, I'm trying to go kind of as fast as I can because I know this is a lot of stuff and I don't want to waste your time. You can always pause and go back on certain questions as well if you understand other questions. But I also put number 8 in here from the practice exam. So this is the one about the baseball. I think you guys had a homework problem like this too. But if a baseball is hit into the air and its height h in feet after t seconds is given by h of t equals negative 16t squared plus 96t plus 1, what is the height of the baseball when it is hit? So, you kind of you have to imagine again, right? A baseball is being hit. It's going to go up in the air and then it's going to go down, right? The arc might be a little bit different depending on how it's hit, but it will be an arc, right? But anyway, basically what we need to do here for the first question is find out what is the height when it is hit. So when it is hit, what is the height? Well, the thing we have to ask ourselves here is when it is hit, what is the time? Well, the time in this function would be 0 because this function represents the ball or the baseball's height in feet after t seconds. Well, it hasn't been hit yet, so it hasn't been in the air at all. Okay, so basically here, the time or t, right, our t variable equals 0. So what does that mean? That means we take our function and we plug 0 in for t. We have h of 0 equals negative 16 times 0 squared plus 96 times 0 plus 1. Well, this is very simple because 0 squared is 0. 0 times negative 16 is 0. And 96 times 0 is 0. So we just get 1. So really, what's the height? It's just 1 foot. Okay, when the ball is hit, it's 1 foot up in the air. So, that's not very high. If you know baseball or if you're a baseball player yourself, that's kind of a low pitch or something to be hitting there. After how many seconds does the baseball reach its maximum height? Okay, well, the maximum height, so that would be up here, right? Well, after how many seconds does it do that? Well, in order to figure that out, we need to figure out the vertex, right? So we would need the x value of the vertex, because if you think about this here, the height is going to be on your y-axis and the time is going to be on the x-axis. So we would need the x value of the vertex to find the maximum height. So very simple. Again, the x value of the vertex, we know that that is the equation negative b over 2a for any parabola. So this is going to be negative 96 divided by 2 times negative 16. So it would be negative 96 divided by negative 32, right? 2 times negative 16, which equals 3. So 3 feet, 3 seconds. Right? So after 3 seconds, it has reached its maximum height. And then what is the maximum height? Well, that is going to be the y value. right? Oops, the y value of the vertex. So we just take this 3 that we just found and we plug it in for t, right? Plug it in for the time in our original equation. So we have negative 16 times 3 squared plus 96 times 3 plus 1. And this is going to be negative 144 plus 96 and 3 is 288 plus 1, which is equal to 145. And that's a height, so 145 feet. All right, next section was on transformations and translations of parabolas. And I pretty much just called it shifting the parabola here. But let me just write down a few notes from this. So we had that our base function of a parabola was f of x is equal to ax squared, or we could say y equals ax squared. Okay, and in any x squared function, right, in any x squared function without anything in it, the vertex is going to be right there at 0, 0, right? So the vertex here, v, is equal to 0, 0. And again, if a is greater than 0, it opens up. If a is less than 0, it's going to open down. Okay, but we learned kind of some different things here with this. So we learned that, let's say the function was 1/4, or sorry, y equals 1/4 x squared. What the 1/4 does to our base function is it actually makes it wider. Okay, so this is going to widen out the graph here. Okay, so the 1/4 makes it wider. So I could say that the graph is wider. Okay, but also if I had y equals 4x squared, what's going to happen there? Well, that's actually going to make the graph narrower. So it's going to be closer to the y-axis. So this is going to mean that the graph is narrower because of the 4. Okay. We also learned, if I had something like this, y equals x squared plus 3. What does the plus 3 do to our base function of y equals x squared? It's going to move all the values up 3 units. Okay. And another example, let's say I had y equals x squared minus 3. Okay. This is going to move everything down 3 units. So everything is going to shift down 3 units. Okay. And then we had where maybe it's like y equals x minus 5 in parentheses squared. Okay, now the parentheses is going to tell us here that this is actually, now the minus sign is going to do maybe the opposite of what we think. This is actually going to move everything to the right 5 units. Okay, and then another example, if I had x plus 5 squared, this is going to move everything to the left 5 units. So kind of interesting there. Take a note. You don't remember that. And then let's put it all together now. So let's say I had y equals 1/4 times x minus 4 squared plus, I don't know, 10. Okay. Well, what's going to happen here? Well, this is going to mean that the graph is going to be wider than y equals x squared. That's what I mean by wider. And then it's going to shift y equals x squared to the right 4 because of the x minus 4. And then everything's going to move up 10. Okay, so just some kind of an overview of transformations and translations that we learned. And now let's kind of do some examples that you'll see. So we might use Desmos or not. I'm not sure yet, but for f of x equals parenthesis x plus 3 squared, do the following. Sketch a graph of the equation. Okay, so one thing that you could do to do this is, I mean, you could use Desmos. I do want you to know how to do it by hand though. So like you could know what the graph of x squared looks like. That would be one way to do it. The other way to do it really is to just make a table of values. So if you make a table of values, well, we know here that what is this doing? Okay, what is the, this is really y equals x plus 3 squared. What is this doing? It's moving everything to the left 3 because it's x plus 3 squared. So this just moves the vertex 1, 2, 3, 3 to the left. Okay, so I know that the vertex is going to be right here. I just need to figure out 2 other points. Okay, I need to figure out 2 other points. So one of my points again is -3, 0, right? You would just plug in -3 to the original function and look, -3 plus 3 is 0. 0 squared is 0. Well, let's pick 2 other points. So maybe like -4. Okay, so let's plug that into the original function. -4, again, if you've been watching my videos, sometimes that happens. I'm not sure why. -4, I didn't want to write that. -4 plus 3 squared is equal to -1 squared, which is 1. So another point here would be at -4, 1. And then maybe let's do -2. So it would be -2 plus 3 squared, which is also equal to 1. So here's our other point. So just a very quick sketch here of this parabola. It would look something like that. Hopefully better than that. Maybe not as squiggly as mine is, but let's identify the vertex. Okay, we already did it. The vertex is right here. It's at -3, 0. Okay, now if you really wanted to, if you totally forgot everything, on the transformations and translation, you could take this function and you could, FOIL this out. So what does x plus 3 squared mean? Well, by the way, it doesn't mean x squared plus 9. Okay, it means we have to multiply this out twice. So it means we have to take x plus 3 times x plus 3, which is x squared plus 3x plus another 3x, which is 6x plus 9. And then what we would do here is we would find our vertex by using x equals -b over 2a. So -6 over 2 times 1, which is -3. Oh, look at that, -3. Plug it back in for our y value and we would get 0. So that's where our vertex of -3, 0 comes from. And then for part C, I believe this question is a kind of a multiple choice. It would say, compare the graph of y equals f of x to the graph of y equals x squared. And again, this is just a horizontal translation. It's moving it horizontally to 3 places to the left. Now, the next part on 11.2 was to basically differentiate between standard form and vertex form. Okay, standard form is y equals ax squared plus bx plus c. So what we've been talking about for any quadratic. Vertex form is y equals a times x minus h squared plus k. All right, so here, this is where the vertex is h comma k. All right, so this is going to be the vertex form. When you have an a value, you have a quantity being squared and then plus another value. And I'm going to go through an example here where number 13 on the practice exam asks us to write the write the vertex form of a parabola that satisfies the given conditions. Then we're going to write the equation in the form y equals ax squared plus bx plus c. Some people get this question wrong because they just write the y equals ax squared plus bx plus c part. They forget about doing vertex form first. But for this problem, they already gave us the vertex. Okay, so they gave us the vertex here of 4, 1. So What does that mean? Well, that means that I can identify, remember our vertex is h comma k. So I can identify what a, h, and k are. Well, a is equal to 2. They gave us that. H is equal to 4, and k is equal to 1. So if I want to do the vertex form of this, okay, so if I want to do y equals a times x minus h squared plus k, that's the vertex form that we just talked about, then I just substitute. So a is equal to 2, h is equal to 4, and k is equal to 1. This is our vertex form. Okay, now to find the equation in our standard form, this guy, all I do is I take the vertex form and I simplify it. Okay, so I'm going to take this guy and I'm going to write out maybe the x plus 4, sorry, not x plus 4. I'm going to write out x minus 4 times x minus 4. So I have 2 times x minus 4 times x minus 4 plus 1. And then I just keep simplifying. So let's FOIL these two guys, the x minus 4. So that would give us x squared minus 8x plus 16. Okay, distribute the 2. So I have 2 times x squared is 2x squared. 2 times negative 8x is negative 16x. 2 times 16 is 32. And then I had the 1 at the end there. And then just combine the 32 and the 1 for our like terms. And this is our, this is our standard form. So again, this is standard. And then this is going to be our vertex form. Let me rebox this one so that if people are just reading the notes, again, you always have the option of reading notes there. I always post those. I think you have to download the PowerPoint though if you want to read the notes. So anyway, that's how we do number 13 on the practice exam. So we're about halfway done. Let's go to section 11.3 on quadratic equations. So again, our standard form of a quadratic equation is ax squared plus bx plus c. In an equation, in this case, I'm going to set it equal to 0 here. Okay. And we talked about a few things with these. We talked about when these have maybe no solution, one solution, or two solutions. Okay. And we said, so let's say we have an equation kind of looks something like this. So this is the actual graph of a parabola. This is going to have no real solutions. Okay, and why is that? It's because this parabola does not intersect the x-axis at all. So another way to say this, that it has no real solutions, it has no x-intercepts. What does that mean? It has no point where this function crosses the x-axis right here, right? Doesn't cross the x-axis. Well, what if we had a function like this? Okay, something like this, where it touches at one point. Okay, touches at one point. Well, this is going to have one real solution. Okay, and that's why, again, because it has one x-intercept. And then a function like this is going to have two real solutions. And again, why is that? Because it crosses the x-axis at two different points. So it has two x-intercepts. X-intercepts, again, are just points where a function or a line crosses the x-axis. And we learned a whole bunch of different ways to find solutions to quadratic equations, right? We graph them, right? And then we would look at where does it have intercepts, sorry. We factored them. That's something that we kind of mostly did in chapter 6. And I didn't tell you at the time that actually, maybe I briefly mentioned it, but I didn't tell you that when we factored, we are also using the zero product property and then finding what would essentially be the solutions to those equations. Okay. We had the square root property, okay, where we use, so maybe something like 25x squared minus 16 equals 0. And then we took this problem, and I'm going to skip some steps here, but we basically add 16, divide, and then divide by 25. So x squared equals 16 over 25. We take the square root of both sides, which makes it plus or minus. And then really, essentially, we have two solutions. We have positive 4/5 and negative 4/5. Okay, so that's kind of how the square root property worked. It was kind of a shortcut to, maybe factoring or something like that. I mean, definitely something like this would be a difference of squares, right? Where you could factor it into 5x minus 4 and 5x plus 4. But then, this is just kind of a shortcut to that method here. Then we completed the square. So we started that in section 11.3. And we continued it on in 11.4. And then finally in 11.4, we did the quadratic formula, which actually I could always use to find solutions to quadratic equations. Let me do some examples now. So number 15 on the practice exam kind of looks a little complicated, but it's very easier than it actually looks here. It says, a graph of y equals ax squared plus bx plus c is given. Use this graph to solve ax squared plus bx plus c equals 0. What are they asking for here? Okay, all they're asking for is the x-intercepts. So where does this function intersect the x-axis? Right here. And right here, what are those 2 points? I think the first point is -4, 0, and the next point is -1, 0. So all they want there is the x intercepts -1 and -4, or -4, -1. Okay, and I don't remember what the directions say on this, but you could also write those as ordered pairs, so -1, 0, and then -4, 0. I think this is the form that they want, but just in case. And then number 16, this was kind of a couple points to this question. One was to review factoring, because we also, we covered that way back in chapter 6, but we also need to know it here as well. But the other point, excuse me, is that we can also use things like the, so we can use factoring to solve it. We can also use the quadratic formula. That's what I was getting at. So we can also use the quadratic formula, but let's just do a little bit of a review on factoring here. So if you remember, if we had a quadratic equation that looks something like this, basically, we are multiplying the first term, the first term's coefficient with the last term. So we take 5 times -69 to start off, and that is -345. And we're looking for factors of -345 that give us an 8. And so you can kind of see why this is a little bit difficult, but luckily 345 is divisible by 5, I know, because the last digit ends in a 5. So 5 times 69 is 345, but I can't get an 8 out of 5 and 69 by adding or subtracting, but I can do it with 15 times 23, where 15 would have to be the negative factor, right? Because -15 plus 23 is equal to +8. So what we do there is, if you recall from chapter 6, is we split the middle term here. So I have 15x squared minus the 15x plus 23x. This was the splitting, right, of the middle term of 8, right? Because this is 8x right here. And then minus 69 is equal to 0. Now we take this and we group it, right? So we group these two together and we factor out a common factor. So we have common factor of 5x squared and a minus 15x is 5x. So we take a 5x out of both of these, and we have an x minus a 3 left over there. And actually 23 is a common factor in this one. So we take out a 23 there. We have x minus 3 again. And now we kind of, a common factor here is x minus 3. We take that out, and then we also have the 5x plus the 23 left over. And now we use the zero product property. And we set each of these factors equal to 0, and we solve for x. So we set x minus 3 equals 0. We set 5x plus 23 equal to 0. This one we add 3 to both sides, so x equals 3. This one we subtract 23 and then divide by 5. So we have negative 23 over 5. So your answer would be negative 23 over 5, comma 3. Again, you can always check those, plug them back into the original equation, check to see if you got the right answer. 19, we started completing the square. So we learned how to complete the square here. So let's go ahead and just review this example and how to do that. So completing the square, again, it's just another way of finding the solutions to a to a quadratic equation. So in order to complete the square, first we have to know, is the first term a 1? And it is. So I don't have to do anything special. If it wasn't a 1, I would need to divide every term by whatever this coefficient is and then continue on. So I would need to kind of have a 1 in front here by dividing that. But I do have a 1, so I'm just going to move on here. So our first step here is to move this negative 7 to the other side. So I add it to the other side, it becomes a positive. Now I want to add to each side of this equation. I want to add to each side this guy. I want to add b over 2 squared, whatever that is. And in this case, all right, in this case, and I didn't really say it here, but in this case, what am I using? Dark blue. In this case, a is equal to 1, b is equal to 12, right? C is equal to negative 7, just for good measure. But in this case, b is equal to 12. So I just go ahead and I plug in 12 for b. And then I take 12 divided by 2 and I square it. So 12 divided by 2 is 6. 6 squared is 36. So on this equation, I add 36 to both sides. And the whole point of that was the trinomial here on the left side of this equation is now a perfect square trinomial because the x squared term and the 36 are both perfect squares. And the square root of 36 is 6, and I know 6 and 6 is 12. So I can go ahead here and say that this guy is x plus 6 quantity squared. Again, x plus 6 squared is x plus 6 times x plus 6, which would FOIL out to give you this trinomial. And then 7 plus 36 is 43. So I have completed the square, right, by getting that 36 term. And now I'm going to basically take the square root of both sides. So I'm still solving for x. So let's go ahead and square root. So if I square root this guy and I square root this guy, I need a plus or minus here. So I have x plus 6, right? The x or the squared goes away because squaring a square root just gives us the inside expression, so x plus 6. And then when I square it to 43, I do have to plus or minus it. And then I subtract 6 to both sides. So I minus 6 here, that cancels the 6 out. And I have negative 6 plus or minus the square root of 43. And then this plus or minus tells us we need, to break this into 2 different answers. One answer is negative 6 plus the square root of 43. And then the other answer here is negative 6 minus the square root of 43. So that is a very quick general overview of completing the square, kind of working through that example. And then the last section of chapter 11 was the quadratic formula. So this formula is really awesome because I can use it to find the solution of any quadratic. Okay. So I really don't need to know how to graph if I know this. I don't need to know how to factor. I don't need to know how to complete the square. I don't need to know how to do the square root property. Okay. And actually kind of an interesting fact is some countries, when they teach math, they only teach the quadratic formula so that you don't need to know any of the other methods. Here we kind of like to have almost a holistic approach to quadratics. And quadratics, guys, I know this kind of seems like really, I don't know, like remedial, not in that sense, but it's kind of just like repetitive is basically the word that I want to use here. You're doing all of these calculations and it just gets to be really, really repetitive. Well, quadratics are really important because we use them. I mean, they're everywhere. Anytime you throw something in the air, okay, you could model that using a quadratic equation. Okay, if you hit a ball, if they're used in physics and just all sorts of things. So that's kind of why we talk about this. And if you move on to other math classes, this will come up again and again and again. So you do have to know this formula and quadratics, factoring, graphing them, all that inside and out. But the quadratic formula here, kind of, sorry for that little lecture, but solutions to any quadratic can be given by this formula. Okay, x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So let's do some examples here. Okay, solve this quadratic equation by using the quadratic formula. So the first thing you're going to do here, we have 5x squared minus 7x minus 3. The first thing we're going to do here is we're going to identify our a term. We're going to identify the b term, and we're going to identify the c term. Well, a is the coefficient in front of x squared, so it's a 5. B is the coefficient in front of x, so we have a negative 7. C is the last term, negative 3 there. And again, these kind of have to be in order to pick out A, B, and C. So if it's not in order, right, if it was, if I had, let's say 3x, let's say I have 2 minus 3x equals negative 7x squared, I would need to put this in order, right? In order to pick out A, B, and C. So I would need to, maybe I could leave the 7x minus 7x squared over here, and then I would need to add the 3x over and subtract the 2 over. So now I could pick out the A, B, and C from this example, right? And I would get those, negative 7, 3, and negative 2. So let's go ahead here and let's do the quadratic formula with these guys. So I have, again, negative b plus or minus the square root of b squared minus 4ac all over 2a. I think one of my not elementary, but maybe middle or high school teachers had a song about this formula or something. If you want to Google those or YouTube it, you can do that if you want to remember it. But you guys get to use notes and stuff for your tests. So don't be weary about that. Just write it down, then you don't have to remember it. But anyway, let's go ahead and let's plug these in here. So I have negative b. So I have negative times a negative 7. So be careful about that step. This is a negative b and b is already negative. So it's a negative times a negative. Plus or minus the square root of b squared. So negative 7 quantity squared minus 4 times a, which is 5, times c, which is negative 3, all over 2 times a. So all over 2 times 5. So I have negative and a negative is a positive. So 7 plus or minus negative 7 squared is 49. And then I have 4 times 5 times 3, which actually is 60, but I have 2 negatives. So that gives me a positive 60. And then 2 times 5 is 10. And I just keep going from there. 49 plus 60 is 109. That's not a very nice number. That doesn't give us a perfect square or anything. So from this step here, we just break this into 2 different answers. So we have 7 plus the square root of 109 over 10. And then our other answer is 7 minus the square root of 109 all over 10. And that's what x equals for these. Again, why is it x equals? Because those are x-intercepts. Those are the x-intercepts of this quadratic. Okay, and if you calculated these with your calculator and you got some decimals here, which they don't want. Okay, they do not want decimal answers for these. If you did that, you would get some really weird long not repeating, but non-repeating decimal. These are the exact answers here. And when we do this, we want exact form. So we're never really going to change these to decimals and round them, at least in this class. But you guys kind of get the idea there. So that's an example of the quadratic formula. And then this is just another example, just kind of reiterating that solutions to this or any quadratic, so solutions to factoring a quadratic, to completing the square, etc., are x-intercepts of the quadratic. Okay, so let's go ahead, let's take this guy, let's do another example. If you want to pause it, you can do that and try to figure this out on your own. So what's the a value for that one? Well, it would be the -2. What's the b? That would be -7. And c is -3. So let's go ahead and plug that into our quadratic formula. Again, let me just copy it down. -b plus or minus b squared minus 4ac all over 2a. And so this is equal to negative times -7 plus or minus the square root of -7 squared minus 4 times the a value times the c value of -3 all over 2 times the -2. And this, I'm going to move it up here, is going to give us 7 plus or minus the square root of 49. 4 times 2 times 3. That is, let's see, 4 and 2 is 8. 8 times 3 is 24. We have 3 negatives, so it's a -24. All over 2 times -2 is -4. And 49 minus 24 is 25. That's a nice number, unlike the last one, because I know the square root of 25 is just 5. And then from here, I can break this guy up into 7 plus 5 divided by -4, and then 7 minus 5 all over -4. So this gives us x equals 12 over -4 and 2 over -4, which is -3 and -1/2. And those are your answers there. And again, these are x-intercepts. So really they're oops, do they want us to do, oops, it says type an ordered pair. So I just had that incorrect. So it says type an ordered pair. So I would have got that wrong. So one of your ordered pairs is what? -3, 0. And then the other ordered pair is -1/2, 0. All right. And then I think I just have one more concept, and that is the discriminant. Okay. So the let's see. So the discriminant here, right? So that is let's see, kind of where was I going here? Oh, yes. Okay, so that is when we determine the number of solutions to a quadratic equation, okay? And we kind of already talked about it, right? It's basically what the discriminant is, or what it is it's the number inside the square root in our quadratic formula. So if I have negative b plus or minus the square root of b squared minus 4ac all over 2a, the discriminant is, the discriminant is this part. It's this guy in here. So if that ends up being positive, so if it's greater than 0, we know that there are two real solutions. Okay. And again, what would a quadratic look like that has two real solutions? It would look like this guy. If our discriminant ends up equaling 0, there's going to be one real solution. And that graph again looks like this. Okay, but we don't need to know the graph here. We just need to know what the discriminant is. And then a graph like this would be when we have no real solutions, because there are no x-intercepts, right? And if this is the case, we actually have two complex solutions. And if we have a complex solution, we actually write them in standard form or standard complex form, which is a plus bi. And I'm going to go over an example of that here in a little bit. But number 24 on the practice exam says, do the following for the equation x times x plus 5 equals -7. Evaluate the discriminant. So what we're going to do here is we're going to take this equation and we're going to find the discriminant of it. And the first step that we do is we need to distribute the x out here. So I have x times x is x squared. X times 5 is 5x. That equals -7. Let me actually move the -7 over here to be a +7 so that it actually looks like a quadratic equation. And now what we're going to do here is we have to identify, A and B, and I'll just identify C as well, because we're kind of pretending that we're doing the quadratic formula, but we're just finding the discriminant. But A here is equal to 1, B is equal to 5, C is equal to 7. Now, all we have to do for this is find what B squared minus 4AC equals. That's the discriminant. So we just substitute 5 for B. We substitute, I always put a parentheses around the 4. That's just a habit. Just so I don't lose that, this kind of negative right here. And then A is 1 and C is 7. Actually, I do need the 7. I forgot about that. I was thinking vertex. But I have 5 squared, which is 25. 4 times 1 times 7 is 28. All those are positive, and I have one negative here. So I have negative or minus 28. And I know 25 minus 28 is -3. So this is our discriminant. Well, what happens when it's negative? There are no real solutions, right? Option 3 here, B squared minus 4AC, we just got -3 from all that. It's less than 0. So that automatically tells me because -3 is less than 0, we have no real solutions. Interesting, okay? So no real solutions in this case. What does that mean? That means the graph will not touch the x-axis at all, right? So if I did graph this, let's go ahead and do that. Let's go to Desmos. Okay, and you can write out the standard form, or you could write the x times the x plus 5 in brackets there equals -7. I'll just write out the standard form. And I'm just verifying that this graph, I haven't even checked this, hopefully I'm right, does not touch the x-axis, and it doesn't. Okay, this does not touch the x-axis. By the way, I think you can just say it's equal to 0. Oh, maybe not. Okay, you have to just keep this not equal to 0 anyway. But and again, you would actually get the same exact thing if you if you did this without writing it in standard form. X parentheses x plus 5 equals negative. What does it equal? Oh, I thought you actually could do that. Never mind. I learned something new about Desmos. You have to write it in this standard form if you want to do that. So we verified anyway that this does not touch the x-axis. So there are no real solutions. There are imaginary solutions, right? And we would do, how would we figure those out? Okay, how would we figure out the imaginary solutions there? Well, we would do the quadratic formula, right? And that would tell us the imaginary or the complex solutions. Okay, but let's go ahead and let's try an example like that. So you will get complex solutions in this example. And I could have done it with the other example. I just didn't, but let's just use a brand new example. So the discriminant here, I can guarantee if you tried this really quick, b squared minus 4ac, let's see what the discriminant is. It's going to be 9 minus 36. It's going to be negative 27. So I just verified that the discriminant on this case is negative. There are going to be complex solutions here. There are no real solutions. So let's go ahead and let's find what those are. And I just did A, B, and C here, but I'll just write them down again. A is equal to 1, B is equal to 3, C is equal to 6. Let's use our quadratic formula to find those. So we have negative B, or negative 3, times B squared minus 4 times A, which is 1, times C, which is 6, all over 2 times A. So I have x equals negative 3 plus or minus the square root of 3 squared is 9. 4 times 1 times 6 is the 24. Oh, I messed up. I messed up the discriminant up here. Anyway, it is going to be negative. But I put 24, sorry, I put 36 for some reason instead of 24. This is 9 minus 24, which is actually going to be negative 15. So that's this guy all over 2. So I have negative 3 plus or minus 9 minus 24 is negative 15. There's our negative 15 as I got for my discriminant up there. I just did it again down here, all over 2. So we have what? Well, we have, I'll put x equals, I'm going to move it up here. We have negative 3 plus or minus, what's the square root of negative 15? Well, that would be I, right? I square root of 15 all over 2. That's going back to chapter 10, where you take out the I, which is a square root of negative 1. You leave the 15 on the inside. And then here, I'm going to break this up, just like I broke up some of the other ones before. Except I'm going to have this complex number here, this I value. So I have negative 3 plus I square root of 15 all over 2. And I have negative 3 minus I square root of 15 all over 2. And again, you kind of have to write these in A plus BI form. MyLab will accept these answers. In fact, this is the same form that I used on your lecture notes for section 11.4. But really, you should write them like so. You should write them as negative 3 over 2. Oops, I kind of broke them up here. Negative 3 over 2 plus square root of 15 over 2 times I. So I kind of goes out in front there of the fraction. And then the other one would be x equals negative 3 over 2 minus the square root of 15 over 2i. And those would be your two complex solutions in A plus BI form. Again, I think, MyLab will accept these answers, but just to be safe, you might want to answer them like this. I do go over all of your exams after you're done and you submit them. And if I see an answer like this, I will accept it. It'll just take me a little bit more time because I'll have to go into it and, click and give you the point or whatever. But just so you know, anyway, that is, I believe, our review for chapter 11. So I'm going to stop sharing. We actually have only one more chapter left for this semester, and we're going to go back to chapter 7 after this. But I really appreciate you guys for hanging in here with chapter 11. It's kind of been a little bit longer, even though it's 4 sections. And thanks for watching today. And we'll see you next time for chapter 7. Take care.